Welcome students, we are back with another lesson. So today we'll discuss scalar product. What is it? Or dot product of two vectors A and B. Let us say this is your vector A, this is your vector B. They are both connected with their tail. So your two vectors A and B is defined as the product of the magnitude of A and the magnitude of B. Fine. So the dot product of this two vector will be the product of the magnitude of its, and the magnitude for this one will be mod of A, or I can also write as A. Fine. And the magnitude of this one will be mod of B, or you can also write it as B. So it is defined as the product of the magnitude of A bar and B bar and the cosine of the angle between them. So the angle between them is how much? Theta. Therefore, I can write the dot product of A dot B is equal to magnitude of A, magnitude of B times the cos of the angle between them, or I can also write AB cos theta. Fine. Moving on. Vector product. The vector product or cross product of two vectors is defined as the vector whose magnitude is equal to the product of the magnitudes of the two vector and the sine of the angle between them. Fine. So if you have two vectors, vector A and your vector B, so the vector product of this two vector will be this third vector A cross B. And how we will write A cross B? We will write A cross B as magnitude of A, magnitude of B times the sine of angle between them. And the angle between them is theta. So I'll write AB sine theta, which I can also write as AB sine theta n cap. Now note, why have I denoted n cap? N cap denotes the position vector. Can you see? This is the direction of A, this is the direction of B. The result you get after multiplication of these two vectors, you get a third vector. This is a vector. So the direction of this one is n cap. Whereas in the previous case, we had a scalar product. That was not a vector. But this one is. Therefore, if it is a vector, that means it has a direction. And this direction is denoted by n cap. Fine. Now, whenever we need to measure the direction, okay, of the two vectors, or let us say the cross product, or when we need to know in which direction our resultant vector will be, so for that what you will do, since in the question they have given your A vector and your B vector and the angle between them theta. Fine. So what you will do is you will take your fingers. Fine. Now you will see from which direction to which direction is being multiplied, from A unit vector from A vector to B vector. From this vector you are multiplying to this vector. Your finger should curl from your direction A vector to your direction B vector. As you can see in the figure, my fingers are curling across A to B. Fine. And can you see my thumb? This thumb is pointing upwards. This denotes the resultant or the vector product of these two vectors. So this is known as your right hand rule, which can be used to find the direction of your vector product. Moving on, next we'll discuss circular motion. If a particle moves along a circular path with a constant speed, that is, it covers equal distance along the circumference of the circle in equal intervals of time, then the motion is said to be a uniform circular motion. Suppose this is a circle. Okay, let me draw a better circle. Fine. So suppose you have a particle at this point. If this particle covers equal distance in equal interval of time, suppose it covers this one in some time, again at same time it covers the equal distance, again at same time it covers the equal distance, again the same time at equal distance, again the same time at equal distance, and so on. And if it covers the same distance in equal intervals of time along the circumference, that is the boundary of the circle, then we will say such kind of motion as your uniform circular motion. Fine. Now note, there is no direction for your uniform circular motion. Okay, what is happening is that at every instant you are changing your direction. Okay, so this is an important point while solving numericals. Fine. Okay. Next, we'll discuss about angular displacement. The angular displacement of a particle moving along a circular path is defined as the angle swept out by its radius vector in the given time interval. So we know what is a displacement. Displacement is the shortest distance traveled by a body in a given time interval. Fine. So let us consider a particle which is at A, or a body which is at A. After some time it travels and reaches to the point B. Okay, so this body was first at A with respect to P naught. After some time it has reached to the point B with respect to P naught. Right? Now, in that case, what will be our displacement? The displacement will be the difference of this two position, which is how much? Delta S. So this is your displacement. Now, what will be your angular displacement? The angular displacement will be the angle swept by its radius vector. Okay, so let us say for the particle at position A, how much the angle it is making? Theta 1. For the particle which is at position B, how much angle it is making? It is making theta 2. So how much angle it has swept? It will be the difference of theta 2 and theta 1. So this is del theta. Therefore, how much will be your angular displacement? The angular displacement will be del theta, del S. That means the displacement or your displacement covered in a certain time interval. Del S, displacement covered in certain time interval, divided by your radius vector. Fine. To relate this one, we can also use our basic formula which we have studied in our previous classes. Your angle theta equals to arc. This is your arc. This distance travel is the arc divided by your radius. Fine. So my angular displacement equals to del theta by del S by del R. Fine. And it is measured in radians. Moving on. Angular velocity. The time rate of change of angular displacement of a particle is called angular velocity. Okay. So if this is a circle, let us say this is the angular displacement your body has covered. Now after some time your body has covered this angle. Now after some time your body has covered this angle. So how fast the angular displacement or how fast the angle of the particle is changing, we'll call it as your angular velocity. Your angular velocity can be written as, or it is denoted by omega, and it is written as del theta by del t. Del theta is your angular displacement divided by del theta is your time interval. So it is measured in radian per second, and its dimensional formula will be m0 L0 t to the power minus 1. Fine. And why is it so? Because theta doesn't contribute anything to the dimension. There's no m or L. The only part which is contributing is your time. and time is in denominator, so you have t to the power minus 1. So dimensional formula m0 L0 t to the power minus 1. Moving time period. The time period taken by a particle to complete one revolution along a circular path is called its period of. Suppose my particle is at this point. Fine. Now how much time it takes to travel this whole distance is known as your period of revolution, or it is also known as your time period, and it is denoted by your capital T, which is measured in seconds. Moving on, we have frequency. The frequency of an object in a circular motion is defined as the number of revolutions completed per unit time. Fine. So let us say, suppose we have a particle which is at this point. Okay, this particle is undergoing a uniform circular motion. Now note, this particle, let us say it takes 5 seconds to complete one revolution. So what will be its period of revolution or your time period? 5 seconds. Fine. Now let us consider another case. Okay, in this case a particle is moving, but this time it is moving little bit faster with comparison to your first case. Fine. Now this time we note it has taken 2.5 seconds to travel this whole distance. So if I'll ask you how many times it will cover this circle, or how many times it can complete one revolution in 5 seconds. So in 5 seconds it will cover this distance twice, whereas in first case it will cover this distance only one time. Fine. Now let us consider one more case. Suppose this time it has taken even lesser time. Let us say it has taken 1 second. So if I'll ask in 5 seconds how many times it can cover a distance, in 5 seconds let us say 1 second, 1 revolution, 2 second, 2 revolution, 3 second, 3 revolution, 4 second, 4 revolution, 5 second, 5th revolution. So how many times it has covered the circumference of the circle or this distance? 5 times. So can you notice the difference between the first, the second and the third? The difference in the number of revolutions completed per unit time. Fine. Now this difference or this quantity is known as your frequency, how fast it covers or at what rate it does the stuff. This is known as your frequency, how frequently it can do the stuff, right? So the frequency is denoted by your nu, and the symbol nu. So I can also write the formula for frequency equals to nu equals to 1 by t, and it is measured in hertz or your second inverse. Fine. Now moving on. We have the relationship between angular velocity and linear velocity. Fine. Now we know what is your angular displacement. Angular displacement equals to del theta divided by del s by r. Fine. Now what we can do is we can divide both sides by t. I have divided both sides by t, as you can see in this figure. Sorry, as you can see on the screen. Del theta by del t equals to 1 by r del s by del t. Fine. Now what I will do is I will take the time interval. What does this delta t denotes? The time difference. Okay, or I'll say the time interval. Let us take this time interval very small. Okay, so here the limit delta t means I'm taking the time interval to be so small that the difference is almost equal to 0, not 0. Fine. So limit delta t tends to 0. Fine. So I can write limit delta t tends to 0 del theta by del t is equal to 1 by r of limit delta t tends to 0 del s by del t. Fine. Now note, your limit delta t tends to 0 del s by del theta can be written as d theta by dt. Fine. Now d theta by dt, what is the rate of change of angular displacement? It is your instantaneous angular velocity. Fine. So omega is your instantaneous angular velocity. Similarly, let us consider this part. Limit del theta tends to 0 del theta by del s, which in turn equals to ds by dt. Now what is the rate of change of displacement? It is instantaneous velocity. Fine. So I can substitute your values here. This limit del theta by del t will be your omega. 1 by r will be, I will write it as 1 by r. Now limit delta t tends to 0 del s by del t will be your velocity v. Fine, I can send this r to the other side, therefore I can write v equals to omega r. Therefore linear velocity equals to, this v denotes your linear velocity. This equals to your angular velocity omega times the radius. Now this is an important relation, v equals to omega r. Fine. Now move on. Angular acceleration. The time rate of change of angular velocity of a particle is called as angular acceleration. So what is your angular acceleration? How fast your angular velocity is changing is known as your angular acceleration. Your angular acceleration can be written as alpha, or it is denoted with alpha. Now alpha equals to del omega by del s. Fine. Del omega is the angular velocity, del s is the displacement, or let us say the r. So I can write alpha equals to del omega by del s. Fine. Now the angular acceleration is measured in radian per second square. Radian per second square, and the dimensional formula will be again m0 L0 t to the power minus 2. See, this radian does not has any dimension, so the only part contributing to the dimension will be second, and second is time. So what is the power of time? To the power minus 2. So t to the power minus 2. Fine. Now note, your linear acceleration can be written as your angular acceleration times the radius. Your linear acceleration, your normal acceleration a, can be written as your angular acceleration alpha times the radius along which it is covering a uniform circular motion. Fine. I can also write my alpha. Okay, this is alpha. My angular acceleration, okay, or as b square by r. V square by r. And we know what is my v? V is r omega. Now if I substitute this value here, what happens? This will be, this is v square, right? So this is v whole thing square divided by r, which will be in turn r square omega square divided by your r. This r and this square gets cancelled. What am I left with? Omega square r. So I can also write my angular acceleration as omega square by r. Fine. So this type of acceleration is known as your centripetal acceleration. Okay. What is centripetal acceleration? I will explain it to you in our next class. Fine. So that's it for today's class. Thank you. And if you have any confusion, please feel free to ask. I will re-explain it to you again. So thank you.